Hello everyone, this is Zichuan from Shanghai Jiaotong University. The topic of our research is optimal operation of the green port logistics system for consumption enhancement of offshore wind power. The presentation has four parts: background, main contributions, modeling, results analysis, and conclusion. Firstly, let me introduce the background. Due to the high carbon emission of fossil fuels, there is an upsurge in utilization of the emission-free energy resources like wind, solar, biomass, and so on. Among these renewable technologies, wind is the most economic, prominent, and mature one. Offshore wind power plant is an emerging technology in the wind energy conversion system. Nearly 40% of the total wind capacity is expected to come from offshore wind energy in Europe in 2030. Thus, the green port concept with low carbon emissions is proposed. The logistics system is the most significant component of a port, which directly provides all port services for vessels. Power demands of the logistics systems are large and fluctuant due to the handling equipment with intermittent operation time. Thus, an operation strategy for logistics system can fully utilize the flexibility of logistics system, significantly reducing its operation costs and emissions. In this research, the logistics system consists of key cranes, yacht cranes, and river containers. A green port logistics system is mainly designed for the delivery of river containers, which take up about 40% of our total power consumption of a port. And meanwhile, river containers have huge potentials of flexibility due to their massive quantities and available power ranges. Renewable energy sources are the main facility to reduce carbon emissions and air pollutants in the green ports. In this thesis, offshore wind power plants are the renewable energy source. Let's move to main contributions. This paper proposes an optimal operation strategy for the green port logistics system to enhance the consumption of offshore wind power. Management of the key cranes, yacht cranes, and temperatures for river containers are considered in the optimization. Output power of offshore wind power plant, ambient temperature, and electricity price in the main grid are considered as the input parameters. The photo at left-hand side is the framework of the proposed overall system. The logistics system transports containers from container ship to stacks. The system consists of offshore wind power plants and electrothermal conversion, logistics equipment including key cranes and yacht cranes, residential loads, container ships, and river containers, river stacks. Now it's come to the modeling. The objective function is the minimum total costs, including the electricity costs, renewable energy purchasing costs, and curtailment costs. The rest of containers such as constraints, such as tideline power, wind power, power balance, and so on, are not listed in these slides. In terms of logistics system, the number of containers handled by key cranes and yacht cranes during each time interval is shown at here, where Qy and the number of containers handled by key cranes and yacht cranes are binary variables to decide ship I is served in the berth, with Q containers delivered by key cranes and Y containers delivered by yacht cranes. Other constraints including handle limit, temperature, and thermal power bound, and so on, are listed in thesis. In the temperature rise and fall processes of the river containers, the temperature rise is determined by the temperature difference between the inside and outside of the river containers, mass and the specific heat capacity of cargoes, size and surface area of the container. Now I will show you simulation results and analysis in this part. This page illustrates the results for the operation of the logistics system. All containers are transported to stacks in corresponding berth duration. The overall power demand of logistics system is relatively high when the electricity price is low or renewable power supplies are sufficient. The cooling process for the river containers are carried out during the periods with relatively low electricity price or redundant renewable power supplies. The operation results of the energy system are shown in this page. Due to the proposed strategy, the then generated power from offshore wind power plants are fully used. More electricity is purchased from the main grid through the timeline when the electricity price is lower. This is the comparative study as shown in the table. It shows that the proposed strategy can achieve higher consumption rate of the offshore wind power and lower operating costs for the logistics system. Overall, this paper proposes an optimal operation strategy to use the green port logistics system for enhancing the consumption of the offshore wind power. Management of the key cranes, yacht cranes, and temperatures for the river stacks are considered in the proposed strategy. Simulation results show that the proposed strategy can increase the consumption rate of the offshore wind power as well as decreasing the operating costs of the green port logistics system. It indicates that the proposed strategy is a win-win schedule for both the green port and the offshore wind power plant.